welcome everyone to my talk about offline first web applications. Did you all get some coffee? Yeah. Oh, perfect. So we're off to a good start then. All right. My name is Max. I'm a front-end developer at Swiss web hosting company Scion. I'm the co-founder of my own company called Living Room Events, where we create a platform for digital events. I've been a web developer for the last 10 years, and most of this time I've been working in front-end development. When I'm not working, I love to travel. This is my first time here, by the way. It's such a beautiful island. I really enjoy it here. And I love to go hiking. I love to go running. I love to go mountain biking, everything outside. You can find me on Twitter at mquelle. All right, I'm going to be talking about offline first web applications today. I will start with a little introduction. I will show you the web technologies that make it possible. Then I will show you some of the tooling that is already around, and in the end I will talk to you about the approach that we chose for our own offline first application. So first of all, why am I even here, right? As I told you before, I work for a web hosting company, and we offer like classical shared web hosting. And well, one of our biggest products basically is email. And every hosting customer of us, they have at least a few different email accounts set up. And it's really something that is used daily by thousands of customers every day. And yet, this is what they see right now. This is Roundcube. This is our webmail application. Now, don't get me wrong. Roundcube is amazing. It's really cool. It has been around since like forever, and it does a really nice job. It's just it's quite old already, and it doesn't look that fresh anymore. So I was tasked with building a replacement webmail client for our customers. And when I started thinking about how could I do this, it was clear to me immediately that it needs to be a progressive web application, a PWA. But what even are progressive web applications? So the term progressive web application, or PWA, has first been coined in 2015 by the Google Chrome team. And they defined it as a new generation of web applications which should resolve the following criteria. So first of all, they should be fast, meaning they should load instantly. Then they should be integrated, like they should feel like it's part of the device. They should be reliable, so they should work without or with a bad internet connection as well. And they should be engaging, so it should be possible that users can interact with it without having the app open. But if we are talking about the progressive web applications that are already out there today, I would argue, and this is just my own personal opinion, of course, I would argue that most of them are not really progressive, right? And I will tell you what I mean by that. So here is Twitter. And Twitter is always praised for its great PWA. Yet when you open Twitter without an active internet connection, this is what you see. So it loads instantly, right? It's here, you see something. It's just that you cannot read any tweets. And if you try to send a new tweet, it's not possible, nothing happens. You cannot even read your messages. But it's still better than the next example. The next example is Gmail. And this is what Gmail looks like without the internet connection. Now, I ask myself, like, why are native mail applications better? Because native mail applications can do that, right? They can, you can use them without an internet connection. You can read all your downloaded emails, you can send new emails, write new emails, respond to emails, and it gets synchronized as soon as you have an internet connection. So in Switzerland, where I'm from, there's a lot of people commuting to work every day by train. And that's a lot of time spent in the train. And like in the train, you probably would like to already like read your emails and like take a look at your emails, maybe respond to your emails. But at the same time, in a train, you oftentimes don't have an internet connection, and if you do, it's kind of flaky. So my goal was, with our new webmail client, it should be possible that someone in a train could use this. So let's look at the technologies, at the web technologies that can make this possible. So first of all, there's service workers. They are the most basic part in all of this because they make web apps work offline. Web service workers can be installed from a web application. They run in the background. They can intercept requests. And they can communicate with web applications. Now, this talk is not a deep dive into service workers, but it should like give you an overview of what kind of is possible with them. This is how you would install a service worker, right? So you would do like navigator.serviceworker.register, and then you link to your service worker JS. And what you get back is a service worker registration. And the registration can have like one of a few different states. First one being installing. That's why while it's in the process of being installed. The next one is waiting, is when it has been installed, but is waiting to replace the currently active service worker. And active is, well, when it's active. Now, you can think of a service worker like a kind of a browser extension that is being installed from your web application, because it's not directly part of your web application anymore, and it can also run even if your web application has been closed, and it sits like in between the web application and the server, meaning that all of the requests from your web application go through the service worker. And in the case that the server is not available, even if the server is gone or if the internet connectivity is gone, then the service worker itself can respond to the requests from the web app itself. Now, what makes this possible is the cache API. The cache API allows us to interact with the browser's cache. Now, the cache API can only cache request-response pairs, and it can be used inside the service worker. This is how it would look like. And now this code is from inside the service worker. So first of all, we wait until the worker is installed, we open a new cache, and we add /cat.jpg to the cache. That means that the browser does a request to cat.jpg, and it caches the response. Then we can listen to fetch events from our web application, and we can check the URL. And if the URL, in this case, we check if it's a doc.jpg, we just respond with the cached version of cat.jpg. Meaning the web application wanted to load a picture of a dog, but instead we respond with an image of a cat. So as you can see, this allows for some bamboozling. Now, another amazing API is the background sync API. The background sync API allows us to do requests when the site has already been closed. It has to be said, this is not the standard, and it's only supported in Chromium browsers, but it does not require permission. This is how it would work. In our application, we basically wait for our service worker to be ready, and then we use sync.register. We give it a tag, in this case maybe create user, and then in our service worker we can add an event listener to those sync events, and well, if it's like create user, then we do the create user request, basically. Now, if there is connectivity, then this is executed instantly. Otherwise, it only gets executed when a connection has been re-established, and this can be after your web application has already been closed. So this is really cool, right? If you want to like save some user's actions, but the user already closed the web page, you can still synchronize those with the backend. Now, the pros of this API are obviously you can do requests after the page was already closed. But in my opinion, there's a few cons as well. First of them being, I feel it's kind of an awkward syntax. It's a bit weird. You need some kind of application logic in your service worker, so separation of concerns becomes a thing. And as I said before, it's not a standard. But we will see. Hopefully, it will become a standard some point in the future. The next really important part that we need for building offline-first web applications are storage APIs. There are different kinds of storages in the browser. First of them being cookies. Now, cookies have been around since web browsers, basically, and they allow us to save little pieces of text, like session IDs or access tokens, stuff like that. Then we have web storage, which includes local storage and session storage, which is basically a synchronous key value data store. And then in the end, we have IndexedDB. IndexedDB is basically a full-fledged database right inside your browser. Now, when it comes to storage limits, we have the cookie, where we can save like 4,096 bytes. That's not a lot, right? That's like, it's enough for some access token, stuff like that, but not much more. Web storage allows us to save 10 megabytes of data. That's already a lot of text if you think about it. But then, when we start to look at IndexedDB, the storage in theory is unlimited. Now, this is a screenshot from Chrome DevTools from the web application that we are building, and as you can see, we are using 115 megabytes of storage, most of that being from IndexedDB. And that's quite a lot of storage, I think. But it also shows you that the available storage quota is like 596 gigabytes, which is crazy, but also not really possible since I only have like 200 gigabytes of free disk storage here. So this is not always very accurate, unfortunately. Now, being able to save this much in your browser is really cool, right? But there's a catch, and that catch being is the LRU policy. Now, the LRU policy is triggered as soon as the available disk space on your computer is used up. And the browser's quota manager starts to clear out data based on the least recently used policy. And it basically just deletes data until there is enough space to fulfill the one request that triggered the policy. Now, This is kind of bad news for our offline first web application, because when we want to save our users' actions and in maybe like in IndexedDB, and maybe they have not yet been synchronized with the backend, it could be that the LRU policy is triggered and our data gets deleted, our unsafe data. Now, there's something we can do though, and this is the persistent storage API. Now, the persistent storage API allows us to make data persistent instead of temporary. It is not yet supported on Safari, unfortunately. It can be requested by any web app, and it makes your data persistent instead of temporary. And that includes all of your data, basically. That's cache, that's web storage, that's IndexedDB, that's cache, that's everything. So if this is activated, you don't have to worry about the browser cleaning out your users' data. And this is how you would ask for it. First of all, you would probably want to check if your browser supports it, and then you would just do navigator.storage.persist, and you will get back a Boolean value if your application has been granted the right to persist data or not. So this is either true or false. But how is the persistent storage permission granted? Well, on Firefox, it just asks the user. The user can say yes or no. And on Chromium, it's a bit more difficult. The browser itself looks at how high is the level of the site engagement. It looks at if the site has been installed or bookmarked. And it also checks if the user has already granted the permission to show notifications. Now it takes all of this into consideration, and it tries to make a decision for the user. So this is something you need to keep in mind, because you should not ask for persistent storage first point when opening the web application, but that only after the user has already interacted with it a bit. And then there's additional APIs, right? There's a lot of APIs that we do not really use to create offline first web applications, but they are definitely empowering and can make us help feel web applications more native. This is, for example, a file system API, the file API, notifications API, push API, and you get message and broadcast channels as well, and many, many more. Now, all of those APIs, except the background sync API and the persistent storage API, are supported in all the major browsers today, which is good news, because we are already able to develop offline first web applications. So let's take a look at the tooling that is already around. So first of all, there is a Workbox. Workbox is a set of libraries and tooling for service workers. It is built by Google, and it consists of different modules and libraries. It comes with a lot of different caching strategies whatsoever. So if you want to or have to implement your own service workers, you probably want to work with Workbox. It makes your life so much easier. Then another interesting part of the tooling that is already around are replicating databases. The first of them being PouchDB. Now, PouchDB is like a JavaScript implementation of CouchDB, of the CouchDB database, and it can run inside your browser. And with PouchDB, you can basically have a replication of a CouchDB instance right in your browser. Then there's RxDB, which is kind of similar. It's also like a replication inside your browser, but it builds like a real nice real-time interface on top of it. Now, when we talk about offline-first web applications, we kind of have to talk about Hoodie, because Hoodie pioneered offline-first, I think, as well as serverless applications. So it was built on top of PouchDB, and it consisted of a client library that could be used together with the provided Node.js backend. So you didn't have to think about your backend logic at all. Now, this project has been discontinued at one point, but nowadays there's like a lot of modern alternatives. First of them being like Firebase with Firestar by Google, MongoDB Realm, and then we have AWS Amplify and Datastar. Now, all of those solutions make it really easy for you to develop serverless applications, and you get the added benefit of making it really easy for creating offline-first applications. Now, let's look at the approach that we ended up with. So this is like an overly simplified diagram of how our architecture looks like. We have like a little REST API that is communicating with like mail servers and CartOff servers. And we have our front end that is just communicating with the REST API. Now, this is not really a conventional backend, and we do not really have the ability to choose a database, so we cannot really just use a CouchDB, for example. And we are also like dependent on third-party systems. Now, with that being said, it's like it's not really possible to use like replicating database inside the browser, and it's not really an option to switch to like Firebase or something, right? Also, when we looked at how we thought it should work, we had some like special use cases, I think. So this is a diagram of what should happen when a user sends an email. So first of all, regardless of connectivity, there's two things that should happen at the same time, right? So first of all, it should remove that email from the drafts folder and then decrease the number of active drafts. And at the same time, it should add this email to the sent folder and increase the number of emails in that folder. And as soon as there's connectivity, the email should be sent, and the sending either is successful or not. If it is successful, we just want to show a notification, I guess. But it's not successful, then we want to reverse all those local changes that we made. We want to put the email back in the drafts folder, and we probably want to show a notification as well. Now, all of those things are not really possible with the tooling that I already talked about before. So we took some inspiration from this guy. This guy, well, this is a hermit or an eremite, and hermits they live secluded from society most of the times out of religious reasons. They are like spending their time meditating and reading important books, and only from time to time they have some interaction when someone like comes to them, brings them food, maybe brings them a new book to read, and but they live secluded from society, and they do not really have like an active connection and only like sync up from time to time. So we started implementing our own JavaScript library, and we called it Eremite JS. Eremite JS is backend agnostic, so it should work with all possible backends, REST APIs, GraphQL APIs, and whatsoever. It is built on top of Vue3's reactivity API, but it can be used with really any front-end framework. It's just a JavaScript library. It is independent from service worker. Like if you are working with Eremite, then you just need a service worker to make your web app work offline. And it could be used in native applications as well. So if you think about like Electron or like React Native, it could work in there too. And Eremite JS is like meant to be or to replace your logic layer. Now, in this diagram, you can see the Eremite star is like right in between the web application itself and the service worker. The Eremite star is where most of the logic happens. It is where the requests are being made to the backend. And it has a lot of state, which is being persisted into an IndexedDB. Now, inside of Eremite, you have different kinds of resources. And resources are meant to like replicate the resources you might have in your backend, but it's not really necessary. You can structure it however you want. But this is how you would like implement one of those resources, right? We have a settings resource. We use the class syntax for this. Now, first of all, every resource has its own state. And here we implement just like the initial state, which is being shown before anything has been loaded. So here we set like the language, default language is English, and the notifications are not enabled by default. And now we might have a method called fetch, where we fetch the settings from our backend and just write them to our state. Now, as you can see, Eremite makes use of the decorator API. The decorator API is, you may already know from frameworks like Angular or other libraries as well. It is like right now it's in the process of being standardized. It's a stage 3 proposal now. So hopefully it will be in the standard JavaScript like very soon. With this queuable decorator, we say that this method should not be immediately executed, but instead it goes through our central action queue. Every Eremite star has its own action queue, and the action queue basically is being paused when there is no active connection to the backend, and it is being resumed as soon as there is connectivity again. Now, we might have another method called update settings, where we just do like a patch request to update the settings on our backend. And here we use the queuable decorator as well. And what's really cool is we can now define a mutate decorator. And the mutate decorator allows us to like manipulate our local state before the action itself has been executed. So in here, what we want to do is we want to update the local state in a way that that we assume the backend will update our state. So in here, we just overwrite our local state with the provided settings. And this allows us to already work with the new settings. Maybe the user changed their language. So the application can already work with the new state, even if this action has not been persisted in the backend just yet. Now, this is a very simple resource, and here's how we would use it. Here we create a new star, new Eremite star. We give it a name, my star. We add the resource, the settings resource, and we can specify a connection indicator. The connection indicator is like a little helper that determines if the star is connected to the backend or not. And now, we just use the standard browser connection indicator, meaning if the browser is offline, then our star is offline as well. But we could just see if maybe our backend is available as well. So this is a very simple use case. Let's look like a more practical example now. So this is like our sidebar in our webmail application, and we see a list of different folders, and next to each folder, and there's like a little badge that shows the number of unread messages in there. Now, if we open an email, then we automatically set this email as we mark it as being read. And so what should happen is in the sidebar, it should like decrease this number, right? And if an email that has already been read is being marked as unread, then we want to increase this number. So we could implement a method called toggle read, and this is probably in another resource. It's maybe in a mails resource, right? Where we just take the folder, the mail ID, and the read value, which is a Boolean, true or false, and yeah, we just do a patch on this resource, right? Now, when we want to implement now the mutation for this, we would like find the item in our star, and we set the read to read, which is either true or false. And then we can use a little helper method called mutate resource state that allows us to mutate another resource state. So what we want to do is, if an email has been read, we go to the folders resource, and we find the folder, and we set the unread count to either plus or -1, depending on if the email has been read or not. Now, I would love to like live demo this, but it's not really possible because like the application is not yet in production. But I took a little screencast. Now, what's going to happen here is this is our email application. As you can see, we are in the inbox. There's 2 emails in the inbox. One of them is unread. One of them has already been read. And in the sidebar, it shows 1 unread email for our inbox, right? Now, first of all, I'm in the Chrome DevTools. I set the network to offline, so the web application thinks there is no email connection, no internet connection. Now I toggle it as read. As you can see, it marked it as unread. It changed the number to 2. It didn't do any network requests just yet. In our IndexedDB star, we can see the action queue. There is 1 active item in there, update email, with the ID and read equals false. And now if we set it back to online, then this action gets executed. It did the request here. It did the patch with the read false. And if we take a look at the IndexedDB now, the action queue is empty. So yeah, this is basically how Eremite works. It allows us to like work with a local state, and yeah, so far it works really well for our own application. Now, Eremite is not yet open source. It's in very active development, as is our webmail application, but it will be, I mean, the webmail application will go into production or like in the beta phase in a few months. And the goal is obviously to make this open source at one point. If you are interested in this, if you think you would like to try out, maybe you want to develop your own offline web applications, I prepared a little form. You can fill it out, and I can start giving people access to to the open source project just a little earlier, and then yeah, you can try it out if you want. Did everyone get a chance to scan the code yet? Perfect. All right, that's it basically. If you think that was interesting, then please make sure to follow me on Twitter at mkveller. From there you can find my website. I sometimes publish blog posts, and you can find my GitHub account as well. With that being said, thank you very much. Are there any questions?
A ver si estaba así.
Hey. Hi there. Really nice. This Eremite looks really good. I wanted just to ask. We had already used JSDay to wrap the IndexedDB. Is it? Could it be used as well, or is that Eremite that this kind of layer that works differently?
So the question was about JSDay and if it could be used with Eremite, right? As far as I understand, JSDay is just like a wrapper for IndexedDB, right?
Yeah.
Eremite actually is based on a local forage. It's like a project by Mozilla that kind of it's like so you can use it with different implementations. You can use it with IndexedDB, but you could also use it with local storage, for example. You just have a lot less storage quota, right? And so no, it would not be really possible right now, just right now, to use it with JSDay. But you could like write your own local forage adapters and use it with any backend, any database, basically. Yeah.
Okay. Thank you.
Any other question?
Hi. So I wanted to know how the queue works. And if it's configurable, if you can change how the priority works for the processes, or if you can change how a task is considered for the queue.
Yes.
In Eremite.
Right. So the question is about the action queue, right?
Yeah.
The action queue, you can like define one action queue for your store, and you can like define a concurrency, like how many actions should run at the same time. But there's also like you have those actions can be dependent on one another, right? So first of all, you could like there could be an action create email, and there could be an action update email. And now it's like really important that those two are not concurrent, right? So they should not run at the same time. So first of all, the create email should be executed, and the other one is basically dependent on this one. You can basically create like dependent chains of actions. But other than that, there's not really a priority built in just now. Does that answer the question? Right. The cube died.
Now, any other question? Yeah. Yeah.
Okay. Thank you for the great presentation, and I love the the history behind the naming Eremite. Great name. I'm just curious, what were some of the considerations you had to decide to build your own? Like, why didn't Realm work for you or Firebase? What were the considerations that went into saying these don't fit your solution, so you had to build your own?
So at least as far as I understood it, those like Firebase or Realm, they just work with those respective services and not really with any backend. And it's just not really, I mean, I guess it would have been possible to like, I don't know, create our own backend on Firebase maybe. Maybe that would have been possible, I don't know. But on the other hand, we are a web hosting company and we kind of have to, well, eat our own dog food, I guess. Yeah. Any more questions? Perfect. Thank you very much.